Hello and welcome to the next video in the Technical Tekton series. In this video, we're going to look a bit more in depth at tasks. We're going to talk about how tasks are implemented, and we're going to explore the Reconcile Loop, which is the mechanism that Tekton Pipelines uses to process tasks and to process the pods that TaskRuns create. If you haven't already watched the first episode on tasks, that describes how to write the YAML for them, then I'd recommend going back and watching that first, unless of course you're already familiar with writing tasks. So to get us started, here we're looking at two terminal windows. On the bottom, I'm going to start a watch of pods. That just means that my command line will show events that happen to pods. On the top, I'm going to create a new task run and immediately start watching for changes in that task run. And what we're going to see is as the task run is created, pod is also created. Pod moves from pending into its initializing state. And when the pod goes into its running state, the task run also immediately enters a running state. Finally, we'll see the pod enter a completed state, and the task run will very rapidly enter a succeeded state. Now, it's difficult to tell, but the pod is the one that's updating, and the task run is reacting to those updates. So what I'm going to do here is just rewind to the last event from the pod, and we can see in slow motion the pod emit its completed event just before the task run goes into the succeeded state. And so we can tell that there is some kind of connection between these two objects in Kubernetes. And what's happening is that events and updates from the pod are being reflected in the status of the task run. So let's dig into this a little bit. Tasks are a type that are defined by Tekton Pipelines. When you submit a task YAML, it's the Tekton Pipelines controller that receives it. Similarly, when you submit a task run, the controller receives it and turns it into a pod. But how does that happen? Well, inside of that controller, we have a reconciler. And the reconciler, we say, implements a reconcile loop. And the job of the Reconcile Loop is to take a YAML description and turn the combination of a task and task run into an actual concrete executing thing, which in Kubernetes is a pod. All right, let's now take a deeper look into that Reconcile Loop and see what actually happens. Okay, so the first thing is the TaskRun Reconciler receives some kind of notification of a new task run. And the first thing it does is it receives that task run data and it looks up the task associated with that task run. The next thing it does is it converts that task and task run into a pod. And here we're talking about a description of a pod. It effectively writes a brand new YAML file describing a pod by taking fields from the task and task run and converting them into pod fields. Finally, it submits that pod back to Kubernetes. Just now, when we were watching the task run and the pod run together, we observed the pod updating status and emitting events while it was executing. While the pod is running, it's telling Kubernetes that its status is changing, and Kubernetes is then reporting those changes back to the TaskRun Reconciler. Okay, let's look at the next step where a pod already exists for a task run, but the TaskRun Reconciler receives one of those updates about the pod status. What it does is it looks up the pod data, it then reconciles the state of the pod with the expected state of the task run. And what we mean by reconciles is that it literally looks at the difference between the state of the pod and the state of the task run, and it says, oh, well, I observe a state change in the pod, and therefore I need to update the task run to reflect that state change. Now, of course, the pod is continuing to execute, and therefore it's going to continue to emit new events and new state changes, and so the cycle repeats again. When those updates happen, they're reported to Kubernetes and ultimately to the TaskRun Reconciler, until we reach a point of equilibrium where the pod has completed, and so the task run is in a successful or possibly a failed state. Okay, what I'd like to do next is take a look at some of the code that's involved in the reconciler. This will be a whistle-stop tour. We won't do anything too in-depth, but I'd just like to go over a couple of the areas involved. So here we're looking at the TaskRun controller file. And a controller is an object that encapsulates all of the different resources required during the reconcile loop. Here we can see a collection of objects called informers. And an informer is used by the controller to listen for changes in the status of resources. So here we're looking at the pod informer. And if we find where it's used further in the file, what we can see is that we are adding event listeners, which listen for changes in the pod, and they filter those changes in pods to those that are related to the TaskRun controller. So thinking back to our reconciler diagram, where the pod events were sent by Kubernetes to the TaskRun reconciler, this is the place in the controller where we are registering to listen for those events. The next place that I'd like to have a quick look at is the TaskRun reconciler itself. So this file here is the core of the reconciler. And as we scroll through it, we'll eventually get to a reconcile kind function. And this is the first place that is called when those pod and TaskRun updates are observed. Now, as we scroll down, we'll eventually find the internal reconcile function. And it's this function that does most of the legwork when it comes to creating the pods or looking at the differences in the pod and the task run. So if you need to make a change to the way that works, this is likely the first place to look. All right, the last thing I'd like to do here is take a look at the logs from the pipelines controller. In order to look at the logs for the pipelines controller, we need to use the kubectl logs command, pass -f for follow, and then we want to look at the controller's pod in the Tekton Pipelines namespace. So that's -n Tekton Pipelines, and finally using tab to complete the name of the pod. We're immediately presented with a whole lot of log output. These are the logs for my controller, which has been running for quite a while now. In another window, I'm going to apply a task run, and we can see how the logs react when a task run is submitted. Okay, I'm going to do that now. And we'll get a flurry of log messages, then a brief pause while the container executes, and finally the last reconcile when the container's done. So it's difficult to see, but those are all log messages of a task run that was executing successfully. When you're debugging and working on the controller, it can be quite difficult if you add log messages of your own to find them in the sea of output as a task run is reconciling. So just as one last short tip here, what I tend to do is I will add a marker to any log messages that I create. Here I'm going to log a message. The first thing you'll notice is that I'm using the log package. And I do that because the logger will wrap the message in JSON, and it's difficult to see that message amongst all of the other JSON lines that are being printed. The other thing that I'm doing is adding a short marker at the beginning of my message, those exclamation marks. Okay, I'm going to apply those changes. And I'm going to follow the logs for the controller. So again, kubectl logs, -f, -n Tekton Pipelines, and use tab to complete the name of the pod. And now again, in the background, I'm going to apply a task run. And we can see here that the log line that I've added is now much more visible. You can see those 5 exclamation marks before the message. So this was just a very quick tip if you're working on the controller for how to quickly identify messages that you leave for yourself. An alternative to leaving a marker is to insert new lines before and after your message. That actually makes them much clearer in the log output, but it causes other messages to be pushed out of the way very quickly. Okay, I'm going to leave it there for this video. Just a very quick look at how the TaskRun reconciler works. Thanks very much for watching.